Good morning, guys. Starting with lesson 19.2 today, going with an all Phillies theme. Old player for the Phil, Scotty rolling in the background. Anyway, I'm going to go through a problem with you. It has to do with graphs, quadratic functions, and today we're going to manipulate the graph up and down, left and right. You'll see. Okay, so we're going to start with the graph that we call the parent graph or parent function, f of x equals x squared, okay? And that's what the graph looks like right there. So if we picked 0 and put it in place of the x, 0 squared would be 0, so the vertex is 0, 0. And then you see the points 1, -1, 2, -2, and how there's symmetry on either side of the y axis, okay, because of the exponent x squared, right? Now this is review, okay? What we learned the other day, if we were to put a fraction into the a spot, ax squared, right, into the a spot, what would happen to the graph? Okay, we just had the parent function, so you can see in blue the parent function is the same in each of the four graphs. And actually this graph right here, where we have 1/2 in place of the a, would make the graph slightly wider. Okay, it would be a more wide graph because of that. So that's review. So now, here's the new material. Okay, we know that the half makes the graph wider. Let's suppose we had an equation where we had x minus 2 in the quantity plus 3. How would that change our graph? Well, as you can see here, the red being our parent graph, the 3 makes it so we move the vertex up 3, and the minus 2, 2 minus 2, the 2 makes it so that we move it over 2. So the vertex started here. The 3 makes it go up 3 to here. Wish they would have done 1 for each, but and then over 2. Do you see that? Okay, I'm going to explain it a little bit further now. Hey, I'm sorry, but my internet's not working on my TV downstairs, so I'm going to have to go right to, where am I looking? Video on this screen right here. It's about a 5.5 minute video. Then I'll give you a little conclusion. Then your problems today will be on Khan Academy. So you'll work off of an assignment there. Go Phils.
So we've been enjoying quadratic functions for a long time together, and I think they're just beautiful. These wonderful curves that are parabolic and have these wonderful parabolas we see all over the place. And it turns out that just knowing the graph of the famous, y equals x squared, we could actually use that as what's called a parent function to actually allow us to draw other quadratic functions graphically and see what their parabolas would look like. Let's take a look at some examples together, and you'll see this is really, really kind of cool stuff. Here's the first one I want us to take a look at. Let's graph the quadratic function h of x equals x squared minus 1. Now, what I want us to do is realize that the parent function here is just the famous x squared function. And x squared, we know exactly what that looks like. That is a friendly, happy parabola, which happy face parabola, centered right at the origin. Goes through 1, 1, -1, 1, and so forth. Okay, so that's exactly what this graph of just x squared looks like. So now what happens when we take x squared and we subtract 1? Well, that's basically taking all the y values. Remember, h of x represents the y values. And we're saying take all the old y values you had and lower them by 1. Lower them by 1. So instead of having the height be 1 here, the height will be lowered by 1 and will be 0. So do you see what happens to the graph? The graph actually drops down by 1. You see how it was originally and where it is now? And that's the graph. So that should be the graph of h of x equals x squared minus 1. Now, we can actually check this for ourselves by just quickly plotting some points. So I'll just plot, let's just actually see if we can compute 1 point. So let's take a look at h of negative 2. So what's h of negative 2? Remember what this function notation means. It means wherever I see an x, I'm going to plug in negative 2. So I see x squared, so that's negative 2 all squared minus 1. And that equals, well, negative 2 squared is 4, minus 1 is 3. So I see that the point when x equals negative 2, the y value should be 3. And check it out. It's exactly what happens. At negative 2, we're at 3. So there's a point right here. Right here. And that's what we see. Right. Well, in fact, you can make up a whole table of values if you want. And this is like one of those cooking shows. I've done it in advance for us. So here it is. Ta-da! As you see, when I plug in negative 2, h of negative 2 is 3. That's the one we just figured out. If you plug in negative 1, we see that h of negative...
Okay, so the point being that this minus 1, like I was telling you on the previous problem, is going to move the parent function down 1. It's still going to stay the same, except for it'll be moved down 1. Let's try to go ahead a little bit here.
But I'm trying to graph x squared plus 1. So that means that every y value now has to be increased by 1.
So we're just going to move the graph that you see right here up 1 on the y-axis. And there it is.
And we see again it's the same parent function of x squared, but now the plus 1 means I raise it up 1. Now, if we plot points to check our answer, ta-da, we can quickly...
So when our function changes by going from f of x equals x squared to plus 1 or minus 1, that's going to dictate moving the function up or down. Now I'm going to give you two. All right, so here's one example. X squared minus 5. The minus 5 moves the graph down 5. The parent function would have had a vertex of 0, 0. It moves it down 5. So we pick A. And then there's a couple of little questions here. The function has a minimum value of negative 5. I'm going to see if I can find that. My keyboard's a little bit tucked away. And the axis of symmetry, x, is going to be equal to 0. And let's check our answer. And we are correct. So now we're going to look at the possibility of the horizontal movement. X minus 4 gives a different component to this. There's nothing over here, so that would be plus 0. But anyway, this is our parent function. And let's see how this x minus 4 moves this graph. Okay, I already did this for you, but you see the x minus 4 plus 0. Really, there's nothing there. So the parent function's in blue, and you can see x minus 4 moves the graph 4 places to the right. Since there's nothing after this, I don't go up or down. I stay completely the same on the vertical movement. Okay, it doesn't go up or down. It only moves to the right 4 based on x minus 4. All right, let's look at one more.
Well, the key is to write this in sort of the standard form for a parabola, which would be x minus negative 1 squared plus 2. And quite often this is referred to as the h value here, and this is referred to as the k value. And so what this tells us is the shift. This is saying that we're going to move this standard picture. So here's the standard, famous, great, we love it parabola, x squared. And this tells me that I'm going to shift it in the x direction minus 1 unit. So that means we're going to go left 1 unit. So we're going to slide it over 1 unit. And then this plus 2 on the outside, this k value, means we're going to go up. We're going to go up 2. So we're going to...
So here's the picture of the new graph. We slid it to the left 1 and up 2.
2 up from the original one. And so by writing it in this sort of standard form, we actually build some insight into even more exotic parabolas. Let's take a look at one last one together.
All right, so that's kind of it from here. Like I said, I'm going to give you a Khan Academy video. It's 3 minutes long. There'll be 4 questions that follow it. Please put some time into the video and then, work those problems out. If you struggle with it a little bit, watch the video again. And have a great day. Go Phillies. That's my Cole Hamels signed picture. But then look, a more current guy signed this for me. You know him? Mike Trout. Pretty nice player from down in Bridgeton area.